Right, so now I've got a whiteboard with a pad that I can use. So can I show you question 6 onwards? Yes, I can. Right, so let me just get question 6 onwards. Right, question 6. Right. Yikes, let's have a pen. So, right. 6 is 1 0 1 0 and then it's 0 1 1 1. Okay, so write this in hexadecimal. Okay, so let me just remind you, this is 1 2.
We can't see your screen, Tom, sorry, we can see you,
Yangs.
but no screen.
Okay, well that's no good, so let's share a screen. And that's the screen I want to share. Thank you for that, Sarah. Okay, so
See it now.
question 6 is write 1 0 1 0 0 1 1 1 in hexadecimal. So I'm just reminding you that these go 1 2 4 8. These are decimal numbers at the top here. These are called nibbles. The whole thing is called a byte, and these 4 are called the upper nibble. These ones are called the lower nibble, because a nibble is half a byte, obviously. Okay, so somebody tell me what this is in decimal and what this is in decimal. Okay, sorry, the upper nibble, 1 0 1 0, what's that in decimal? And then the lower nibble, 0 1 1 1, what's that in decimal? What's what and what's what? Yeah, 10 and 7. Okay, so thank you, Saad. Let's just go over this again. This is an 8. That's not there. This is a 2. That's not there. So 8 plus 2 is 10 in decimal. And in this one, we don't have an 8. We've got 4 plus 2 is 6, plus 1 is 7. Okay, so remember that 10 in hex is actually an A. So in hex, we're going to get A7. And that's the answer in hex. But whilst we're here, says he changing his pen colour, we've got 10 here, but these are the 16s columns, aren't they? So 10 times 60 is 160. Sorry, 10 times 16 is 160. And we've got a 7. So in decimal, that is equal to 167 decimal. So just look at that. We've got binary at the top here. We've got hexadecimal in the middle here. And we've got decimal at the bottom. Okay, Kazim Ali, let's just do that again. In binary, remember in decimal, you've got ones, tens, hundreds. Okay, that's how the columns work in decimal, isn't it? So if I had 567, it'd be 7 units, 6 tens and 5 hundreds. So in binary, which I'm using black, the columns go, so here you've got ones, you multiply by the base, which is 10, so you get 10. You multiply by the base again, which is another 10, so that gives you 100. So in binary you do exactly the same. So you start with 1 and you multiply that by the base, which is 2. And then the next column you multiply by the base, so that's 4. And then you multiply again, 8, and so it carries on. And whilst we're there, let's just do the hexadecimal. You start with the ones, you multiply by the base, which is 16. You multiply by the base again, which is 256. Okay, and that's how hexadecimal works. So you just keep stepping up in that way. So in this case, let's go back to black. Sounds a bit Amy Winehouse. We've got a 1, a 2 and a 4. So 4 plus 2 is 6, plus 1 is 7, so that's where that 7 came from. And in this one, we've not got a 1, but we do have a 2. We've not got a 4, but we do have an 8. So 8 plus 2 is where that 10 came from. So is that okay? So in this, let's just put a dotted line down here, because I've sort of made this into a hex number. This is the 16s column and this is the ones column. And I've done it in binary, and I've done it in decimal, and I've done it in hexadecimal. So that's how you can see all the different numbers and how they relate to each other. Yeah, James, I agree with you. So let's do FF. So let me draw a line here. So in binary, 1 1 1 1 1 1 1 1. Okay, in binary I've got all the numbers in there. So somebody tot these up for me, would you? 8 plus 4 plus 2 plus 1. No, I want 1111 in binary. So what does that equal in decimal? 8 plus 4 plus 2 plus 1. Yeah, okay. What I would do is 8 plus 2 is 10 plus 4 is 14 plus 1 is 15. So in decimal, this will be 15 and this will be 15. Okay, so that means in hex, 15 will be an F. 15 will be an F. So the answer to this is FF in hex. Okay, so that's where that comes from. Right, so I'm using green for decimal. So I've got, this is my 16s column, remember. So this is like 15 times 16. So 15 times 16 is 150. 6 5s are 30, note down 3 to carry, and that's going to be a 9. So that's going to be 240. So that's 240. And this is going to be 240, that is. This is 15. So that is going to give me 240 plus 15 is 255 in decimal. Okay, so 111111, that's all of the numbers, is the same as FF in hex, is the same as 255 in decimal. Okay? And that does questions 7 and 8. Right, how are we doing for time? Can you recap logs? I can. I'm going to go on to one of the trickier log ones because I'm a bit short of time. So what I'm going to do is I'm going to go to question 22. So Zishan, do we have to... Oh, your question's gone. Zishan chat. Do we have to split it if we're getting the same answer without splitting it? Right, Zishan, and this is for everybody. I've shown you one technique. There are loads of other techniques. And if you already know a technique, use the one that you know. My guess is that your calculator has probably got a way of doing this anyway. I'm just trying to show you what underpins the calculator. So if you've already got a method of doing it, Zishan, stick with what you already know. Don't bother changing what you've already learnt. Right, so now what I want to do is to clear the canvas, and I want to do this question, which is log of 6x minus 2 log 2x squared plus log of y minus 2 log of 3x equals 0. Okay. Yes, there is work from this session and it's on baseline. And I guess I need to send out an announcement about that. So let's solve this problem. What it needs is y is equal to a function of x. That's what we're looking for here. Okay. So how are we going to do it? Well, all this is equal to 0. So what I'm going to do is I'm going to leave the y on the left hand side and move everything else onto the right hand side. So what we're going to do is we're going to get log of y. I'm going to do this first because it's a minus sign. So that's equal to 2 log 3x. Okay, so that's that term. This is also negative here, so when I move it onto the right hand side it becomes positive. So that's plus 2 log of 2x squared. And then I've got log of 6x here, which will become minus log 6x on the right hand side. Okay, so let me just do a little bit of simplification. Instead of having the 2 there, I can say that that's the same as log 9x squared plus, and I've got 2, yeah, so I'm going to simplify that. So I'm going to get log of 4x to the power of 4 minus log 6x. Okay, everybody comfortable with what happened there? So I've just taken this 2 there and this 2 there. Yeah, okay, thanks Samuel. Right, so remember that with logs, when you add things, you basically multiply them, and when you subtract things, you divide by the quantity. So that is equal to log, and because these are all x's, I can just do it like this. I've got 9x squared times 4x to the 4. That's right, isn't it? Yep. And that's all going to be divided by 6x. Okay, 9 times 4 is 36, divided by 6 is going to be 6, so that's log of 6, and then I've got x squared and x to the 4, so that gives me x to the 6, divide by x, so that's going to be x to the 5, isn't it? Okay, so now I've got log of something is equal to log of something. I can now take the inverse operation, or anti-logs, or whatever you've learnt. So I can say that y is equal to 6x to the power of 5. Okay, let's bang that into baseline. 6x caret 5, press enter, and it's fallen over. What's going on there? It was question 22, so 6x caret 5, enter. Oh, I've got it wrong. So let's see, what did I do wrong? I've got log, oh no, yes, log 6x, yeah, minus, oh, there isn't a 2 here. Sorry, let me just fix that. So that 2 shouldn't be there. That's a mistake. So that's the 2x squared, so that shouldn't be there, which means that instead of 4x to the 4, that should be the same as that. So that shouldn't be there, that should be 2x squared, which means that I've got 2 9s are 18 divided by 3, so that should be 3x, and then x squared times x squared is x to the 4 divided by it, so that's going to be 3x cubed. So the answer should be 3x cubed. And if I stick that into baseline, 3x hat 3, yes, and that's right. Okay, that's correct. So 10-2. Do you want me to do another one, or have you had enough? Is your stomach rumbling and you need to go? Can I explain the third step with the division? Yes, I can. So right, so what we're saying, let me pull this onto the screen here and zoom up a bit. No, it's not there. No, okay, this doesn't really explain it very well. So let me clear this screen and do that again. Clear canvas. So what we're saying, if we've got x to the a times x to the b, that is the same as x to the power of a plus b. Okay, so multiplying exponential numbers, that's to say a number with an exponent, as long as the bases are the same, you just add the exponents. So dividing, so x to the a divided by x to the b, so it's the same, but instead of multiplying it's dividing, and that is the same as x to the a minus b. Okay, so that's subtracting the powers. So what we had in the question there, if I scroll down to question 22 it was, yeah, we had log y was equal to, let me just write this out, so it's going to be 2 log 3x plus log 2x squared minus log of 6x. Okay, these are all log 10s. I suppose I should put my brackets in for tidiness sake. So we'll stick those in. So that is equal to, this becomes log 3x squared plus log 2x squared minus log of 6x. So let's take these two to start with. So that is the same as log of 9x squared. You see, I've just squared that, times 2x squared minus log of 6x. Okay, so I've dealt with the first two terms, and obviously that's going to be 18x to the power of 4. So I can say that that is equal to log 18x to the power of 4, but now I've got this minus 6x, so I can say that's the same as dividing by 6x. Okay, can I move that up? No, Control Z. So why did I square it? I squared it because of the 2 that I've got here. You see that 2? That gives me basically 2 of these things, doesn't it? So that's log 3x, and I've got 2 of them. And because we're adding, it's the same as raising to the power. This is the hardest it'll get for logs. It is the hardest it'll get for logs, don't worry. So what I've got is 3x here, and that's squared. So 3 squared is 9, x squared is x squared, so that's where this 9x squared came from. Is that all right? So here, what's inside the brackets is it's all squared. It's not just, yeah, you got it, okay. It's not just the x that's squared. It's 3 times 3 times x, which is where the 9x squared comes from. Then I've got 2x squared, which is there. So that's 9 times 2 is 18. X squared times x squared is x to the 4. Then I divide by the 6x, which is what I've got here, which means that I've now got, that is equal to log of 18 divided by 6 is going to be 3. X to the 4 divided by x is x cubed. Right, and now this is a bit of a magical moment because I've got log y is equal to log of 3x cubed. Okay, so that means that I can take anti-logs of both sides, or the inverse operation, or whatever you've learnt at school. We can say that y is equal to 3x cubed. What was that question?
Oh, you went, Tom, for a second.
And have I come back again?
You're back now.
Waha! On the baseline assessment, the answers are filled in for me. Oh, well, lucky you then, is all I can say. I'll have a look.
They are not the only one. There's several students who've said that they've got filled in answers.
Okay, interesting. I'll go and have a look. Right, well, at that time... So, Philip, what do you mean? I'm on the wrong one? Yeah, you've got to log into baseline, and then there should be some questions, but some people are telling me the answers are there, but I'll go and see what's going on there. If we need help, where will be the best place to go? Okay, Thomas, the places to go are the PALs, and they'll be there next Wednesday. You've got, you can email anybody in the team. And Sarah, are you doing any sessions?
I haven't had any set up yet.
Right.
But I suppose if there's a need.
Yeah. Okay.
Yeah, I don't mind.
Abdullah, it's due in before midday next Wednesday. Okay. So, listen, my recommendation is have a go at these today and tomorrow, and possibly over the weekend. And if you've got any questions on Monday, then email me or somebody in the team. So just get onto it now so that you've got your questions, in advance. If you leave it till Wednesday morning, you're in big trouble. Yeah, we've got scrums on Tuesday and Wednesday. So getting back to... was it Thomas? Yes, Thomas, you were asking for help. Have you got a tutorial for next week on Tuesday or Wednesday? Not yet. Okay. Well, I hope that will turn up fairly soon. I'll chase that this afternoon. And we need to make sure that you've got a tutorial, because that's what the tutorials are about, making sure that people get this. No, I don't mean on PALS. No. I mean on Tuesday or Wednesday morning, there should be tutorials for everybody. Okay, I'm going to have to close this. Nothing so far. Yes. It's interesting flip of the fingers there. I'm going to have to close this, everybody. So thank you for showing up. I hope it's not been too messy with the different technologies we're trying to master. Videos of this session and the previous session will be on the on Baseline later today. And obviously, if you're having difficulty, email somebody. Don't suffer in silence. Okay? Woke you up. Good. That's good. Get all those grey cells working, Zishan. Okay. Bye, everybody. Stop sharing. And